So hi to the using Fiji MoBIE for visual QC of CellProfiler and Ilastik output practical. So today will be me, Christian, one of the speakers, and Dominik. So we're both at EMBL. We are actually sitting in the same room right now, so we hope we get all the acoustics right. And so we will mainly do live demos of this, what we want to show. We hope it will take about half an hour, and then we would have half an hour to discuss things. So then let's just start by sharing my screen. And let me go. Okay, actually, check chat. Oh, where's the chat? Here's the chat. So we made a forum post, which I put in the chat. So the idea is that afterwards, if you have any questions about how to redo what we did today, that would be the place where you can ask, and then we will answer there. So here's also our intro slide. So the idea is that quite often one has the situation where one does batch analysis of many images using softwares like CellProfiler, Ilastik, or actually we are here at EMBL now using also Nextflow for this. And there could be, there are many, right? There's Nime, maybe some of you use Galaxy, or maybe just some Python scripts, whatever, right? So, but often you do automated batch analysis. Then what you get is a lot of data, and very typically of the kind that is depicted here. So you have intensity images, so your input data. Then you have your segmentations very often, which are typically label mask images, and you have some measurements as a table. So this is something that in a big fraction of projects, I think, is what you have. So, and then you have to check, is it correct? All of this, right? Did the segmentation work and so on? And also you would like to do scientific discovery. You would like to find interesting, maybe surprising things in this data. That's why you do the science. And how do you do this? Can be a bit challenging because it's so much data. So, and for this, we actually changed the MoBIE plugin in Fiji a little bit. So this was originally developed for something else. Some of you might know, but I will not go there now. So, but basically we realized one can also very nicely use it for this use case. And then you can, we think, conveniently browse through all this data and do visual QC. So that's the idea. And we will today now demonstrate that for having data that comes from CellProfiler, and then I will do that, and then Dominik will show for data that comes from Ilastik, and then we can have a discussion together. So let me go to CellProfiler. So all the material actually that I'm using for CellProfiler is also linked in the forum thread. So there's a GitHub repo, so you can download everything. So I guess some of you might have seen CellProfiler. If not, I will just quickly step through this pipeline that produced the data that we want to QC. So I use the fantastic test mode in CellProfiler. So we have images that have nuclei. We segment them. Then we do a simple segmentation of the cells by just dilating the nuclei. I'm going very fast because this is not supposed to be a CellProfiler course, right? So for this, there might be other tutorials, I guess. Then we actually want to find some spots. They're called PLA. It's some, I forgot the biology, but some important proteins in these cells. So we enhance them a little bit, and then we segment them again by some thresholding. So all standard stuff in terms of CellProfiler. Then what you can also do in CellProfiler is you can then assign each dot to a cell. And this is, so in this project, for example, counting how many dots are per cell was one of the main biologically relevant measurements. Okay, and now comes some stuff that you might maybe not always do when you use CellProfiler, but you have to if you want to do what we will show today. And that is, you have to convert these objects, which CellProfiler internally stores somehow, to a label mask image, where I guess maybe most of you know, where now all the pixels that are object number 2 have an intensity of 2. Object number 6 have an intensity of 6. So a very typical format how you store segmentations. And in CellProfiler, how you do this is this convert objects to image module, and it's important that you say you want to create a new int16 image, because then you can have up to 65,000 different objects. So you need to do that, and then you have to save it, okay? And again, as a 16-bit integer diff. So this is maybe again something that you might not always do when you use CellProfiler, but I actually think it's anyway good practice because this is a very standard way of saving the segmentations. Okay, so this is critical. The other thing that is critical, that in the table that you save, there is 2 things you need to do if you want to be compatible with MoBIE. So first of all, MoBIE later needs to know, obviously, where are all these images. So you have to save the file names of all the images, and also the path names. And we need to know where the cells that you segmented are in the image. So for this, you can either in area shape measure the center of the cell, or you can also save here this location, which they're actually giving you the same. So both would work. So, okay, good. So this is all you have to do in CellProfiler. And then you would just run it. I'd close all open windows, and then what you would get is a folder with a table which contains information about all the cells. Actually, let me delete this one. And these label mask images, right? And just to make the point again, I opened one of them in Fiji, so this is how they should look like. So this is label mask images. And actually, this is also something where you then could go on in Fiji. For example, MorphoLibJ would happily do work with these label masks for you if you want to do further measurements in Fiji. So now, as mentioned, it's tedious now here to inspect all of them one by one, right? You could drag and drop, and that's what people do, all of them in Fiji, and then maybe look at it, does it make sense, and so on. But this is not really, doesn't really scale if you have like thousands of them. So that's why now what you could do is, if you install the MoBIE update site, you can then say plugins, MoBIE, open, and you can open several things. Dominik will actually show you another way, but in this case, our entry point is a table. And it is the cells table that we just stored from CellProfiler. Okay, this is just the plain CellProfiler output, no modifications. And then what you have to do is you have to tell MoBIE which of these columns contain the file names of the images that you want to open. Okay, and they are, I can open this in just a text editor. You see it's just, and this is the file names that CellProfiler gives. So you have to tell it. This is not automated because, as you see, the title here is actually not open CellProfiler table, it's open table. Okay, so this is the idea that this is generic and would work for any reasonable table that you create with any other software. So there's nothing baked in the Fiji plugin that's specific to CellProfiler at that stage. If you all now really love this and want to use this a lot, write it in the forum thread. I could then add more convenience to specifically open CellProfiler tables, but I try to keep it generic because we also produce such tables with a lot of other softwares, as mentioned. So, okay, then you have to just tell it which are the columns that contain images and which are the columns that contain labels, so segmentations, right? This is something you have to specify. then there is something a little bit funny. So there is this equal DNA equal PLA. So this is optional. You don't have to do this. This is just that then in the MoBIE plugin, you have nicer names of things. Then this is not called file name cell labels, but it's actually called cells, right? Which is just more convenient for the graphical user interface. So you can give things basically shortcut names here in the MoBIE plugin. Okay, so then if you have that and you press OK, then MoBIE will open. And okay, so then the first thing is actually what you see is, I will make this a bit bigger. So this is just a standard big data viewer window that you see. It opens all the images at once, and this scales quite well. I think if it's 1,000, it would still be pretty fluent, I think. So, but I mean, let's see. One can always break stuff, but it's pretty good in terms of having a lot of data. So you can just look at them, right? Then we really care about these PLA spots. So let's also add them. So they are now here, and then you can do standard stuff like changing the color. So maybe let's make them orange or something like that, right? So you have standard functionality. You can change brightness, contrast, and so on. Okay, then the other thing you can do is, so here is also it actually created an image table for you, which you can use for browsing. And so for example, if you want to see the data in well2, you can click there and then it would move to where you click at. Okay, so this can be convenient if you want to check something specific. Then if you want to, again, get back to the full overview, there is a convenience. There is this F button that will always focus on whatever is represented in that layer. So for example, if I press F here, you get a nice overview of the whole thing. Then another thing, so you can have convenient browsing of the whole data set. And another thing you can do is so these colors right now are random, but you can actually color it by something you biologically care about. So for example, we color by, and this is these are actually the CellProfiler column names. So there's nothing has been changed. So this is a column where for each image, CellProfiler computed the average number of PLA dots that each cell had. Okay, so if you do a high throughput screen, that's often actually the thing you care about, right? In the whole image, on average, what was each cell doing? So we can color by this, and then we can, for example, here I usually use the blue, white, red. So red is a lot, blue is very little. And then you can actually already here kind of conveniently see which images had most spots. Yeah, so this can be useful. And oops, and you can adjust the lookup table here to have maybe more fine-grained coloring for also some that have just a few cells and so on, a few spots. Okay, then let's add the actual spots, right? So because to judge if all of that makes any sense, maybe we want to see the spots. And now we have the spots also, and this is the label mask images that here are rendered with a just random lookup table. And then we also care about the cells. So let's also look at the cells. Now we have the cell segmentation on top. And here we can do several things. We can, for example, change the opacity so that we can more or less see through the labels. So I think this is important. And another feature that we also provide is that you say, I actually just want to see the boundaries of cells. So here's a settings button, and then we would only see the outlines. I think depending on what you want to do, that can be also useful. And then obviously now, okay, you care maybe in your screen what was the cell that expressed most of these spots? Right, that might be a very natural question you want to ask. And in fact, to be honest, these outliers are often also things where something went wrong, right? So it's a very good way of doing quality control of your data set to look for the extremes. So, and here is this is actually the column that shows you how many dots one cell has. So we can sort and then again click, and it will go to this cell, and it can do that because we stored, this was what I was saying before, the coordinates of the cell in CellProfiler. And here you see this is the cell with the most spots, and you actually also see one reason that is the case is because here the segmentation didn't work very well, right? And then you can kind of discover that and maybe then go back to CellProfiler and try to fix it. And maybe with this, I am done with my CellProfiler demo part. Maybe we can right now, like if some of you have a question immediately or before Dominik shows you something similar. Anybody having a question? See, how do I get an overview? I don't know. A gallery view. Okay, I stop sharing my screen then. Okay, so nobody has an immediate question. Then I would suggest maybe Dominik can show the Ilastik version of this. Yeah.
Okay, hello. There is a question now. Do you want to take it? It's in the chat.
Yes.
Yeah, that's not so basic. That's a very good question, Maria. Thank you. The table itself does not have to be saved in the same folder. So I glanced over something because I didn't want to become kind of too technical, but I can show that again. So let's go there again. And there is, in fact, also something where I think I could still work on, to be honest. So, okay, let's quickly discuss this. It's important. So actually where the table is, doesn't matter. Oh, sorry. Oops, I'm not sharing. Oh, I'm not sharing. Oh, I'm sharing. Okay, I just went back to this menu, Maria, because that will help. So the table can be anywhere. Now, the column that I use in CellProfiler for finding where the images are in fact the file name columns. Okay, so they are pure file names without any folder, and that's why here is this additional field which is called root folder. So you have to give it the root folder of all the images. So that means the table can be anywhere, but with the current implementation, all images, input and output data have to be in the same folder. Otherwise, this logic doesn't work. Okay. So there is also in CellProfiler another column which is called path name, but that actually doesn't store the whole path, but only the folder. So this is makes it a little bit complicated for me. So, but if you have a use case where you would like to have your, for example, image input data and output data into different folders, which can make a lot of sense, and you really would like to use this plugin, then please write it in the forum thread, and then we can discuss how to implement this. But right now, the limitation is that all the images have to be in the same folder. So this was actually not a very good question. Thank you. Any other question? No, okay, thank you. Good, Maria, thank you. Okay, then Domi. Wait, Alex. Can I inspect many images Yes. Yes, exactly. So this is what Dominik will show now. So Dominik will now show you a use case where you have no table, but you still have structured data in terms of input and output. Yes, this is also what we support. Cool. Okay, Dominik, take it away.
All right. So I finally dare to say something now as well. Welcome also from me to this webinar, and I'm going to show you how to do like quality control or visual inspection of your data that you generated with Ilastik. I mean, I'm a software developer of Ilastik, but what I will show you works in principle with any type of software that puts out images, as Tischer in the beginning already showed that we use MoBIE actively with images that were produced by other tools. And as a rough outline is what I'm going to show is that I use this like established data set, MitoCheck, which is a lot of time series of nuclei that are dividing, and ultimately I wanted to track those over time. And for this, in Ilastik, this is a two-step workflow, more or less, where you first do foreground-background segmentation and then the actual tracking in a separate workflow. In principle, both of these steps can be QC'd with MoBIE, and this makes a lot of sense if you train on a lot of data sets, but especially if you do batch processing afterwards, which is often the case, right? You train something and then you want to apply this classifier or this algorithm onto other images as well. And while you can also look, for example, in Ilastik, while you are training, of course, you look at your data. But the big advantage of doing it in MoBIE is that everything is already computed, so it's very responsive. And also it has some other features that I will show you that makes it even more convenient for quality control. All right, and before we get started, a few words on how to organize your data, or like what I came up with on how to organize your data to make your life the most easy as possible when using MoBIE. And like one of the, like how we will load our images, like many images and matching images into MoBIE, we will make use of something that is called regular expressions. And what this is, it's like a form of pattern matching in texts. And I will show you in a second how this looks like. But in short, to make your life easy, we found that organizing your data, like you see it on the left, where all your different types of images are in different subfolders, makes your life a lot easier. And also adding a suffix to these different image types helps you to recognize them in MoBIE afterwards as well. I mean, I think this will be more clear when I show it in action. And some Ilastik specifics, if you're interested. So we will also make these slides available, right, and all the data that was used. But just to reiterate, there is this concept of placeholders for output file names in Ilastik that like needs to be used there in order to produce these new files that have the original file name in the beginning and then some suffix, and this needs to be there in place to match them to the original data. There's a limitation that while MoBIE does support the Ilastik HDF5 image format, it has to, like all the data sets have to have a specific name, which is also the default name from Ilastik exported data. And to make it a little bit easier, I renormalized the probabilities from pixel classification from 0 to 1 to 0 to 255. And from tracking, I exported the object identities in CSV table. But again, I will show this now step by step, how this looks like. Okay, so if we now, let's say, do our first task, which would be the pixel classification inspection, we would go to, first we have to start Fiji. And do not do an update, but maybe in the meantime, I can show you, this is my folder. This is how I organized this folder. So there is this data folder, and in this data folder I have images where I have the raw data, probabilities where I have already the results of pixel classification, and in tracking I have all the results from tracking that I want to show you. And here in the top level I have the Ilastik project files that were used. So if I now go to MoBIE, and in order to open multiple images, and this is what we have from pixel classification, we generated basically a probability image, and we want to view it on top of our raw data. This is why we will take this open multiple images and labels option, which opens a rather large dialog. And the way I do it usually, I mean, now you have to imagine that there's nothing. And you choose your first type of image by browsing to it. And this for me would be the images. And the way I do it, I select the first one. And maybe if we open this in the background here, it might be more apparent. You see, they all have a common prefix, which denotes the experiment, and then they have a position for the screening experiment afterwards, and then the file ending H5. And what we want to do is we want to capture all of these, not only the first one. And this is where these regular expressions come in that I mentioned before. And I mean, regular expressions are an incredibly complex thing, and also very powerful. And so, I mean, there's definitely no way I can explain a lot about this right now, but the only thing to make your life easy, so the only thing to remember is that you can add a dot and a star, and together these two symbols, they will match everything that comes in between. So no matter whether I have this A1 or this A6, they will all be kind of matched and all will be loaded into MoBIE. Okay. So we do the same for the second type of input, which would be the probabilities. I also select the first one, and then I take this, again, this position identifier or some ID that is changing between images, and I replace it by a dot star. And hopefully, if I press OK now, MoBIE opens. Yeah, and maybe if I make the viewer a little bit bigger, oops, I can also show you the data. So these are time series. You can see you can scroll through them. You can go to the different data sets. Like everything Tischer mentioned before still holds. Yeah, to now add our additional probabilities, we go here to this data field, drop down and select these probabilities and click on view, and then they will be shown. What I would recommend now is to change the color of those to something that you like to see, and also change the blending mode to alpha. This means it's overlaid on top of the original image. Yeah, this already looks pretty good. To make it look a little bit better, you can press on V and like increase the lower threshold for this data a little bit. And then the idea is, in principle, that you can manually look at your data, try to find anything that is off or that you don't want to see. For example, if I scroll through here, I can, yeah, for sure, find something that is odd. Maybe here this looks odd, and maybe it makes sense then to look at the raw data before. I could also make a little bit brighter. This. And yeah, this is more or less how you would then manually go through your data, look for suspicious looking things, and yeah, decide whether things were okay or not. And this is, of course, good if you do this, and writing this down would maybe also be feasible, but there is actually a functionality built into MoBIE that you can leverage to record this in a more systematic manner. And this you can do if you go to this image table window and click on annotate. You can start a new annotation. So what this will do, it will add a new column to your table. I will call this QC for now. And you then can add different categories that you want to classify your images in. So I would say, for example, fine is one category, and the next category could be redo, refine, like revisit the training again and do something with this image. And you can also, oops, this was too early. So you can also change the colors for these. For example, redo is probably red, and all fine could be something green. Okay. And if you now go to this region, then you the idea is really you look through this image, and at some point you decide, okay, this is actually all fine. Then you click on the next one, and you then again, of course, you have to inspect it, go through different time frames, decide whether all is good or not. Oh, it is. Then click on the appropriate category. For example, here we could decide now this should be redone, and yeah, so this MoBIE lets you do this in a really convenient and nice way, and you get this nice overview. But also, I mean, what then the ultimate goal would be is you go here to table, and then you can save this table actually as a file that you can then, I don't know, look at in Excel or share with your collaborators, or make a graph like how many data sets were good and how many were bad. Let's see. Okay. So here I could say this is pixel classification QC.csv. And then this file here appears. I can open it with LibreOffice, for example. And there you will see the same as you've seen before. It's like it has the paths to the images. It has like also gives them some ID, and you will have this quality control, whether everything's fine, you want to redo, and all of this recorded nicely linked to the image. Okay, so this is about it for pixel classification. I think I recorded everything I have done here in terms of interactions on the slide as well, so you should be able to follow. And then going on and doing this for tracking, you can also leverage what Tischer showed before a little bit, like that you can add a table and yeah, show different characteristics derived from the table for your different objects. And for tracking, this is super handy, because we then can assess actually how the tracking went. Okay, and this way I will also quickly show. For this, I close MoBIE again, and to load these tracking results, we go to a different menu point, and this would be open image and labels. So what this allows you is to specify three things. First of all, I quickly delete everything that I have here. First of all, you have the image, and this should be the raw data. This I will do exactly as before. I click on the first image, and I exchange my part that is varying with the dot star. Then the label mask. This is something that an image where each object is identified uniquely by assigning it a unique value. In Ilastik, these are called object identities. Yeah, but that is in the end just a label image. So I take one of these object identities, and again, I replace the varying part by dot star. And I do then the same for the table. And the nice thing is that you don't have to jump through too many hoops, as you have seen before, where you have to rename or specify columns. This is already supported by MoBIE for Ilastik tables from tracking. Okay, so if I press OK now, MoBIE should start up. And right away, we say that we want to also see the object identities. And this will take a little time, because this accesses both the images and the table. And the table has to be populated, so you can see it right here. How do I make this a little bit nicer? Oops. Okay, just want to make the view a little bit bigger. Okay, and as you can see, right now, if I scroll through time, the cells have different colors in every time frame. I hope you can appreciate this. So for example, if I go to these two here, it's like changes every time frame. So this is not what we want while we are looking at the tracking results. So for this, we can use make use of like the same mechanics that Tischer showed previously. And this is this color by column. And in the Ilastik tracking table, the relevant column would be the lineage ID, which is basically assigns it a unique value like to a cell and all its daughter cells. And in order to see them in a nice way, we change the lookup table to GLASP and press OK. And then the idea would be more or less like before, like in, I don't know, you go to an image. For me, the easiest is to go backwards in tracking, right? So I zoom in somewhere. And yeah, then in principle, I would then go backwards and see, okay, does it look good? I mean, here we would expect that all cells that divide or now go back together, since we are going backwards, should have the same color. So do we see an event like this here, for example? What's the division? That looks correct. Then here, also a division that looks correct. And it actually looks quite good for this particular data set only. Yeah, and then you can do the same as before, right? You would also add a QC table, QC column to your image table and record your findings like, oh no, tracking has to be redone, or tracking unreliable, or tracking good, or whatever categories you want in principle. Okay. Yeah, that's the object table, and the image table is somewhere hidden here. So here you would get your add your annotation, whereas here you have all the different cells, and if you click on one, then you get flown to it like before. Yeah. So basically, also everything that Tischer previously showed applies to this kind of table here. Okay, so this was basically also what I wanted to show. Are there any questions for this, maybe? Oh. Yeah, okay. Yeah, it's all the tables in one table, but it has the links to, no, I mean, it's different files, and MoBIE concatenates them, but they are still associated with their original file, of course.
You would like to make a comment or say something? We're also happy to see some switched on cameras just for the social aspect of it. Hey, Offa.
Hi.
Good to see you.
Thanks. So in general, if I want to use this to review cell tracking within a whole plate experiment, but when the tracking is done with TrackMate and Fiji and CellProfiler and blah blah, and then the only thing that I need is to take care of the table or file names that will be compatible with this.
Yeah, so it should be, I mean, we try to be as generic as possible. So for the tables, so for the, okay, the image per image tables, okay, so there you can do whatever you want, because actually you specify in the beginning which columns are what. So for the per object tables, right, like where you go per cell or and so on. So there we try to auto-detect what you do. So for example, SK image has a certain way of how it labels the columns where the object coordinates are. Ilastik has a certain way, CellProfiler has a certain way, MorphoLibJ has a certain way. So I think we are auto-detecting these column names. And because in MoBIE, if you then click on a row that is a certain cell, it moves there, which is nice, right? So you can zoom in, but then it needs to know which columns
Did you try
contain.
with TrackMate?
So with TrackMate, we didn't do it, no. So there, but I'm like, if it's a normal, I would be super happy to implement it. Like if you have me a TrackMate table and a label mask and image that belong to that table, that would be something that I would be extremely happy to add. It's a very good candidate, yeah.
Okay.
But not TrackMate right now would not work. Yes.
Okay. We'll try.
Yeah. So Teresa has a question. CellPro segmentations, sure. We do that. So yes. The output of CellPros is, I think it's directly label mask images that are compatible with. I mean, they are label mask images, full stop. So that's what we need. Yeah.
But they are .npy, so.
No. Yeah, not those ones. I think there's also a way to. Yeah, then okay. So we somehow. I think you can tell it. So if we batch run CellPros on the command line, I think you can tell it that you want the output as something like PNG or TIFF. Yeah. So it doesn't work with the NPY. It has to be something that bioformats can open. That's our boundary condition. Everything that bioformats understands should work. Okay. Maria, could we upload any table, any other software? Yes. Theory, yes. So conditions are there must be, like if you just want to have the table as an entry point, then the paths to all the images must be in the table. And as mentioned, so actually what we support is relative paths. Okay, so what is ideal for us is if a table that contains relative paths to images starting from one root folder, and the reason is then you can move your data around, and we just specify the root folder in the MoBIE user interface in Fiji. So this is what we support, because what we kind of think what one should do. But if there is absolute paths in your table, then actually again it might work if you then say your root folder is nothing. If not, I can fix it. So yeah, devil's probably in the details. So again, if you don't try too long alone, right? Just post in the forum thread maybe some minimal example for us, and then I can just try it for you. Okay, so nobody like please just reach out. I think it's easier than struggling too long alone. That's what the forum is for. And if it's yes, so just maybe try once, and if it doesn't work immediately, give some example data. Yeah. And then we can work it out. Okay, anything else somebody would like to ask? Giovanni.
Probably I missed this part. So at some point you show that you can color the edges of your images, so by a field. So, but you can do practically also the same for the single objects.
Yes. So
okay,
there is, yes, there was so each layer that you add to your data, so for example, the objects would be one layer. There's a little button called S for settings, and there you can click show labels as boundaries.
Okay, so I can also do both. So let's say I can have, so the problem is that when you color the edge of an image, so basically you have an average, so you have to take that value from the table.
Yes.
If the table is per single objects.
Yeah, so we have two tables. That was a little bit not, there we were a little bit too fast, sorry, but there were mostly actually two tables. We were just not slow enough. There was always, I think in both examples that we showed, there was an image table and an object table. And you can then separately, yes. That was, sorry, we were a little bit rushed, but
It looked
yes.
nice, but it wasn't
Yes.
clear when
No,
you
no,
used.
no, there were 2 tables.
Perfect. Thanks.
Yeah. And just verifying the recording of this demonstration will be available, right?
I think so. So this is actually not up to us, this is to the organizers, but this was my understanding. So I'm assuming this will be available. Yeah.
Good, thanks.
Okay, anything else? If not, then I think we can close it. Okay, thank you all very much for attending.
Yeah,
And
thanks.
yeah.
It looked super useful.
Yeah, we use it actually really quite a lot ourselves, so it is useful at least once. Okay, cool, ciao.